Thank you for staying. A few people who are staying. Makes me feel like an anti-Corbyn. For the few, not the many. Okay. Right. Let's do this one. As a reward for staying, I will bore you for another 45, 55, or 70 minutes. Depends on when somebody else comes and kicks us out. Okay. Yeah. So this one is. I have a very, very stupid example that I invented myself in the book, where I'm trying to make fun of Manchester City, the football club. Is there anybody here who supports Manchester City? Everyone's too shy. Is there anybody here who supports Huddersfield? Is there anybody here who doesn't care at all about football? Yeah. Excellent. So these people won't be offended by anything they find in the book. What it is about is quite a simple model about how to replace certain parts that fail without warning. Okay? So a typical light bulb will fail without warning because what you know, it works and works and works, and then suddenly boom, and most of the time you don't notice. It doesn't shine less before it breaks completely or anything like that. It just fails without any kind of pre-warning. But that's the same situation. Have you noticed there's something odd in the second bullet point here? Anybody with an attention to detail? Yeah, exactly. There's a comma at the end. So, so another example of these things are, for example, so electric. There are relays that fail like that. So relays are little, in case you don't know, they're little electric components that switch current, open and close circuits depending on a different circuit, and they have the same property. They work perfectly fine, and then at some point they just crash. Or little motors, they usually also do that. But sometimes they don't quite satisfy. Sometimes they start. Where is it? Oh, there. It's not there. Sometimes they stop doing things and so on. Okay. But and so on. It says you could. Okay, I don't want to explain the third thing. What is an important feature here in these situations, or where we can go back now. Go away! I didn't expect people to come back. No, sorry. I'll stay here. Stay here, please. What did I want to write now? Yes. So the situation that we're applying the model. Anybody else? Yeah, so the situation where we can apply this model is one where you have not just one relay or one light bulb or three, but one where you have hundreds or thousands or something like that. Okay, so you have many light bulbs, or many light bulbs. Yeah, let's say light bulbs, and replacing them all at once is much cheaper well, I mean the cost per one item replaced. Yeah? So cost per one bulb. Than replacing them individually. It's only showing there. I know. Do you want it there as well? But so that is this example. For instance, when when you have street lighting, when as a local council, when you decide to replace a whole part of town or a couple of streets at once, and you just send one vehicle with two engineers, and they go there from, I don't know, they go there from Huddersfield, and they replace all the bulbs, and then they go back. Okay, and you get a quantity discount for the bulbs, and you only have to pay them once to come over from Huddersfield, and so replacing everything at once gets cheaper than if one light bulb fails and you call them and they're going to come from Huddersfield and replace the one and then go back again. So the idea is that you have something like this, plenty of items, they can fail without warning, and replacing them all at once makes it cheaper than replacing them one by one. That's the situation. That should be clear. Now, that's the example. So we have 1,000 light bulbs, replacing one, going there, replacing, going back, costs £4. That's the assumption. Stop going over. Okay, but if you decide to replace all 1,000 bulbs at the same time, you only pay £1,000. So it's much cheaper at £1 per light bulb rather than 4. Now, what you need to do in order to be able to solve this is what am I doing? Talking to you, talking with, no, I'm not talking. I'm saying things that don't make any sense. Is that the same as talking with? It's even worse. Okay, so what we are assuming we know is we don't know for each individual light bulb when it's going to fail. But what we do know is what the probability is of it failing in the first month, failing in the second month of its life, failing in the third month of its life, and so on, until failing in the fifth month of its life. The probability of failing in the sixth month of its life is 0 because all these numbers sum to 1, and they have to sum to 1 because they're probabilities of destroying events. Has DAS told you that? No? Doesn't tell you. Who teaches you probability? That's it. That's it. Yeah, so you should have told you that. Okay. So the question is what we do. Okay, before we move on, as an exercise, what am I doing? Why am I here? Go here. As a question, absolutely random question, okay? Belongs to probability theory question. What is the expected or mean life of a light bulb? Okay. How long, on average, does a light bulb of these properties last before it breaks? My question. Okay. It's a probability question. So if you don't know, I'll go to Vas immediately, and I'll tell him, you've taught them nothing.
Isn't the sum of n field red, where n divided by 5, 1 times my optional line, 2 times my 5, so on, divided by 5.
Is it not, or is it?
3.35.
3.35?
Yeah.
How do you know? Well, I can't see that. Can anybody see that? He's showing me a calculator. I've done the calculation.
Sum of the multiple times by value of failure, by probability of its failure. So it'd be 0.1 plus 0.3, which is 2 times by the 0.5, times by 0.75, 1.2.
Like this? But now I have to say why.
That's just how I learned how to calculate it.
Okay. Well, okay, let's have a vote. Who is for accepting this? Who is for rejecting this? You've persuaded a majority. Yeah, so when you have a random variable, it's called a discrete random variable, which means that it only takes a finite number of values, like this. So a light bulb can live for 1 month, or 2, or 3, or 4, or 5. So this random variable, the life of a light bulb, can have 5 different values. And you want the expectation, or the mean value of this random variable. What you do is multiply the value by the probability, the value by the probability, the value by the probability, and then you add them all together. And that's how you get the expected value of that. So in this case, 0.4, 115, 235, 335. Yeah? No. Is it Bayes' theorem-ish? I don't think it is, no. Because there's no conditional probability here. I don't know, maybe you haven't done it yet. I'll ask that. But is it?
Today. Did this morning, just before the end of lunch.
So you see, it's useful sometimes to take things from one module and apply it in a different one, which is a skill that approximately 0.05% of students have. Okay? But it's no, I'm joking. That's not true. Yeah, but so these things are interconnected. You'll need probability here, and you'll need this nowhere else. Okay, we've done this. So what am I saying? Why do we have this? I want assumptions. These are the assumptions. I've talked about them already, except for number 4. Number 4 I haven't talked about yet. Number 4 tells us that in this situation, we are assuming that even if we decide to replace everything once every 5 months, say, then we still have to replace the individual failures as they fail. So we can't say, okay, we're going to do that when we're doing everything. Sorry, but in this particular model, we're assuming that it's safety critical or something. So if, well, it breaks the whole thing down if a relay breaks. So even if we decide that we're replacing everything every 5 months, we still have to replace the individual failures as they fail. That's an assumption. Has anything new appeared? So we have 2 possible courses of action, really. So 2 possibilities. One is replace everything as it fails. And the second is periodically replace everything. Yeah. In the hope that that's going to bring our costs down. These are the 2 possible kind of policies. So number 1 is called the individual replacement policy. Okay, so the individual replacement policy means that we just replace everything as it fails. How much is it going to cost us per month? Maybe too hard. So we know that replacing every single one of them costs £1. Okay, so if every light bulb lived exactly 1 month, how much would we pay for individual replacements per month on average? 1,000, because there are 1,000 bulbs, but I think you have the idea. Okay, so if each of the 1,000 light bulbs failed every month, we would pay £1,000 per month. If each of the light bulbs lived for 2 months, how much would we pay every month? 500 every month. If each of the light bulbs lived exactly 4 months, how much would we pay every month? 250. Do you see where I'm heading? How did you get the 250? Well, the total number of light bulbs divided by how long they live. We don't know how long they live, but we know how long they live on average. Okay, so the monthly cost on average, or in expectation for the mean monthly cost, is, well, £1 is the cost of replacing each of them, okay, multiplied by what? The number of light bulbs, 1,000, divided by how long they live. How long do they live? 3.35. We've just worked it out. No, not £1. £4. Been wrong all the time. Sorry. Not £1, it's £4 for replacing them individually. Sorry about that. But you get the idea. Yeah? So they live on average 3.35 months. There are 1,000 of them. So on average, 1,000 divided by 3.35 are going to fail every month. And each of these replacements costs us £4. So when we do this, I can't do this in my head so quickly, but some of you can. So that's going to be 1,194 a month. Okay. That was simple. Now the second one, that's a bit more complicated than this. So but only marginally. Just a copying. So I need to create a new page. Okay, I'm creating a new page. So it's called the group replacement policy. There are different strategies to survive at university. Some people copy everything that lecturers say. Other people don't care. No, they do care. They pay attention to what's going on and try to understand. And then they ask their friends for the notes. But since Moodle was introduced, you don't even have to ask your friends because we're putting all these things online. But you can still copy everything. I'm not telling you not to. What is the group replacement policy cost? Okay, so how much is it going to cost? So first thing is when we replace everything. Why not? I can see clearly. So you see, you don't have to take notes. It will be on Moodle, so you don't even have to see it now. No. Okay, so when we replace everything, how much does it cost us? Which is 1,000 times 1. 1,000 being the number of light bulbs that we have, which I call a naught, and 1 being the cost of group replacing each of them, being CGR. Okay. But remember the fourth assumption. What is it again? Yeah. Even if we replace everything every now and then, we still need to replace the individual failures. So we'll have to pay for that. So individual failures. C in was £4 per failure each. £4 each. Okay, so now kind of the most difficult part of this whole model is working out how many bulbs fail every month. So how many failures will we have? Okay, so in the first month, how many failures will there be in the first month? On average, yes. So we expect there to be 100 failures. Why? Well, because 0.1 percentage, well, the probability of each of them failing is 0.1. So if we have 1,000, then 10% of them are going to fail. So we're on average, so we're expecting to replace 100 of them. Okay, so I'll call it N1, and it's P1, which is the probability of failure in the first month, times how many we have in all, and the probability is 0.1, and how many we have is 1,000, and so 100 of these light bulbs we're expecting to have to replace in the first month after the big group replacement. That's easy. How many are we expecting to have to replace in the second month? Aha. Well, P2, that's okay, it's 0.15 of the 1,000, so that's 150. Is that everything? And also, exactly 10% of the new ones that we replaced the previous month. You see this now? So among those that we replaced in the first month, 10% are going to fail. So 15% of the ones that we did in the group, when we replaced everything, 100 of them failed. We replaced in the first month. And 10% of these 100 is going to fail again in the second month, on average. Okay, so we have to take P1 times N1. So 150 from the original ones plus 10 of the second ones, that gives us 160. And now, I won't bore you. This is going to be P3 times N0 plus, obviously, P2 times N1. So these are the failures among those that, among those that we replaced in the first month. And then, what am I doing? P2 and then P1 times N2. And in month M is going to be, take Pn times N no, what am I doing? Stop. Pj times Nm minus j, and j goes from 1 to M. Where is it? Okay, that's just a formula for what's happening here. And so yeah, so if the policy is to do a group replacement every n months, what do we get? Oh, this is getting too complicated. Can you see the solution? The cost per n months is, well, what did we call the month cost? So it was N0 times CGR, right? And here it's going to be N1 plus N2 plus, and so on, plus N times, so this is going to be the cost of group replacing everything. And this is the failures in the first month, in the second month, and so on until the cost in the n month. And this is the cost of replacing every single one individually. Does that make sense?
I got too many formulas and no results.
So is this the cost we want to minimize? Yeah, who thinks this is the cost we want to minimize? Four of us. Who thinks that this is not the cost we want to minimize? Five of you, so you win. You're right. Why? Why not? You said no. 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 Someone said no. No, they didn't say anything. They just put their hand up. Okay, so this is indeed not the cost we want to minimize because that's the same question as in the previous hour. You don't want to minimize the cost over the cycle. You want to minimize the average monthly cost. Okay, so the average monthly cost is going to be for monthly cost of the group replacement policy is, what is it? Well, that formula gives us the cost per n months. So per 1 month, it's going to be 1 over n times that formula. So 1 over n times 1 naught CGR plus n1 plus n2. I could put a sum here times C in and bracket 1 to minimize. Okay, it's a function of n. You want to differentiate it. But what you want to do is find the value for each different n. Okay, so you put n equal 1, which means replacing everything every month, and calculate that based on these formulas. You put n equal to 2, which means replacing everything every 2 months, and you calculate all that based on those formulas, and so on. And then you probably stop at something like 5 or something like that. And then you pick the smallest number that you get among these numbers. That's easy. So what's this? This is my way of doing it in a spreadsheet. This is my sketch of a spreadsheet. So what I'm going to do is put all the data at the top. Here I want to calculate the individual replacement policy. So I do the number of failures per month and then the cost of the individual replacement policy. And then when I want to do the group replacement policy, I put that at the bottom of the spreadsheet. Okay, don't even try to understand that. Okay, so these are the things that have just disappeared. Have they reappeared? So you see, N1 is, Okay, so what I'm going to do is P1 times N0, that gives me N1. Then I need P1 times N1 plus P2 times N0, that gives me N2 by that formula. N3 I get by adding these two together, these three together, sorry, and so on. So, okay, there's no point probably in trying to look at it right now, but please, when you get home, it's in the book on page 42 probably, because that's what it says at the bottom here, 42. And try to go through it and understand what goes on there, while for the moment, where's everybody going? Insanity. So if you do implement it, looks like this. These are the probabilities. This is the mean life. We've worked that one out. Then, if you were individually replacing everything as it fails, your cost would be this much. We've already seen that. And if you look at all these numbers, you see that the best policy you can have among the 1, 2, 3, 4, 5 is replacing everything every 2 months. And then that gives you a total expected cost of £1,020 per month. So this is just so you see the actual answer to the problem we started with. But to understand this spreadsheet, read the book. That thing is on Moodle as well, so you can download it and have a look at the formulas and how it works. It might come handy later. Thank you. Any questions? So if not, then have a good rest of the week and see you in the lab.